All right, this is part 2 of rational exponents. We kind of started this the other day, and I thought that we would practice a little bit more before moving on. So you should know how to evaluate some of these questions without me actually telling you how to do it. So think about what exponents with fractions means. Well, exponents with fractions means that you are going to create a root. Now remember that the negative 27 is in a bracket as the original question, so keep it as negative 27 inside that root. This will be actually the cubic root of negative 27 to the power of 4. So then when you go ahead to evaluate this, there are 2 ways that you can evaluate this. And we talked about this the other day when I was in class, but one of the ways is just to do negative 27 to the power 4 on your calculator, and that gives you a big number, which is 531,441, and then to do the cubic root of that. So if we do the cubic root of that number, it actually gives you an answer of 81. The problem with doing it this method is that this number right here might become really, really big, and it becomes kind of a pain to write it down. So what you could do instead is just basically write the cubic root of negative 27, don't forget the brackets again, and all that to the power of 4. So if you remember that the cubic root is a number multiplied 3 times to give you the inside of the root. So that number should be negative 3 here. Oops. And when you do to the power of 4, it's okay. Negative 3 to the power 4 is 81, which is the exact same answer. So it's your choice as to which method you want to use. Okay, so for question B, we have a negative exponent here. And you have to remember that when you have negative exponents, they create fractions. So we're going to create a fraction of 1 over 16. And it's now going to be to the power of positive 0.75. Now you have to just use your calculator and type this in. So it basically is a calculator game at this point. When you type in 16 to the power of 0.75, you get 8. And that's it. So it's just a recap of what exponents are. So remember, negative exponents create fractions. And then when you have exponents that have an exponent that has a fraction, it creates roots. So that's something that you just basically have to memorize or have on your foldable sheet that I gave you so that you can practice it. Now for question C, it gets a little bit more difficult. So this is where the steps come into play. You really want to make sure that you're not doing any negative exponents or any roots right off the bat. So you'll notice here that 8 is already in a root form. We want to kind of get rid of that because it's very hard to understand. So what I do to go the other way is I put my exponents. So this is really 8 to the power of 1. And then inside that root, if there's no number there, it's the square root. Okay, so it's just a little 2 in there. So basically what we have here is a rewritten expression of 8 to the power of 5 over 6. All right, so to continue this, we've got 8 to the power of 1 over 2. So your rules have to be very well set in your minds in order to be able to go back and forth. So the index goes at the bottom, and then the exponent goes kind of at the top. Okay, so very, very important for you to know where those numbers go in order to move forward. So then I just rewrite 8 to the power of 5 over 3. So the next step is to understand that this is a multiplication law and that we have the same base. So you keep the same base and you basically add your exponents because that's what the multiplication law says. I'll just keep that one like that for now. In order to add fractions, you need to have a common denominator, which means I'm going to need to multiply this fraction by 3 in order to get a denominator of 6. Okay. All of this is divided by 8 to the power of 5 over 3 still. We have 5 over 6 plus 8 to the power of 3 over 6, which gives us 8 to the power of 8 over 6. Remember that you keep the same base. You don't multiply them. You keep the same base. So then from here, it's a division law with the same base. So you keep the same base and you subtract your exponents. But again here, we need a common denominator. So it becomes 8 to the power of 8 over 6 minus 10 over 6, which gives us 8 minus 10 is negative 2 over 6. At this point, you can't stop, and you're going to want to stop because you feel like you have nothing left to do, but you still have quite a bit to do. You have an exponent that's negative. So at this point, you want to get rid of that. And when you have a negative exponent, we discussed that you create a fraction. Problem is, now that we do that, we now have a number with an exponent as a fraction. And when you have that, it creates a root. In this case, it's the cubic root of 8 to the power of 2. I like to evaluate 8 to the power of 2, so I like to do that part first. It depends which method you prefer. And the cubic root of 64 is 4. So the final answer is 1 over 4. 1 over 4 is a reduced fraction, so I know I can't do anything else from here. It's a long kind of step process, but this one basically required you to do the multiplication law first. But before you did the multiplication law, you want to make sure that your bases are the same, that you don't have any weird things going on in there. So that's why I switched the root of 8 to 8 to the power of 1 over 2. So that's for example 1. Now moving on to example 2, we have quite a bit of stuff going on here. So again, the steps are very, very important. You want to take care of the basic multiplication, division, and power over power rules before you do anything else. So I'm going to go ahead and distribute, which is basically power of a power. And power of a power means that you multiply the exponents. It's not adding the exponents, it's multiplying the exponents. Now, remember when you don't have an exponent, it's to the power of 1. 1 times 1 over 3 is 1 over 3. Then we have a to the power of negative 3 to the power of 1 over 3, and b to the power of 12 to the power of 1 over 3. We're going to do the exact same thing at the bottom. So 16 to the power of 1 over 2, a to the power of negative 8 to the power of 1 over 2, and b to the power of 12 to the power of 1 over 2. At this point, again, like I said, take care of your power of a power. So I'm going to leave 27 to the power of 1 over 3, just going to leave it. Then I'm going to multiply my exponents. When I multiply fractions, you need to make sure that you multiply the tops, and then you multiply the bottoms. So in this case, we have negative 3 times 1, which is negative 3, over 1 times 3, which is 3. If it helps, put the over 1. It takes 2 seconds. 12 times 1 is 12, and 1 times 3 is 3. That step I find is kind of crucial, doing power of a power before doing anything else. Now down here, I have 16 to the power of 1 over 2. I'm going to go ahead and put that over 1 for both. Negative 8 times 1 is negative 8. 1 times 2 is 2. Now we have b. 12 times 1 is 12, and 1 times 2 is 2. At this point, you want to simplify this stuff. Okay, I'm just going to go over here because I have some writing at the bottom. To simplify this stuff, to start with, you have an exponent that is a fraction that cannot be reduced. So when you have an exponent that has a fraction that can't be reduced, it creates a root. So then it's the cubic root of 27 to the power of 1, which I don't really need to write, so I'm just going to erase it. The next step is to evaluate your a. Negative 3 divided by 3 reduces. It's a to the power of negative 1. 12 over 3 also reduces. So it's important here that you reduce your fractions before you do anything else. 16 to the power of 1 over 2. You put the 16 inside the root. And again, you could put the 1 there if you want, or just ignore it. Negative 8 divided by 2 can be reduced to negative 4. And then you have b to the power of 12 divided by 2, which is 6. You are not done yet. You have to continue to evaluate since the question says simplify. So some stuff can be simplified and some stuff can be evaluated. The third root of 27, if you type that in, is 3. We're going to keep the negative exponents. Like I told you, don't do anything with those until you've covered the basic exponent laws. Power of power, multiplication law, and division law. Right now, we still have some stuff going on. So the square root of 16 is 4. Don't touch that negative exponent, because then if you realize it, we have a division law here. Okay, this one sometimes, I don't know why, but students have a hard time seeing this one. But there is a division here, so I'm just going to do 3 over 4. I can't reduce this fraction anymore. You have to make sure that it can't be reduced. And then I'm going to subtract my exponents, because that's what you do when you have a division law and the same base. So I can only work with the A's and then move on to working with the B's. So again, I keep the same base and I subtract the exponents. So moving on from this, we have 3 over 4, a to the power of negative 1 plus 4, which is 3, and b to the power of negative 2. Still not done, because we have a negative exponent. So these are the secondary exponent laws, as I like to call them. So we have to take care of this negative exponent. Negative exponents create fractions, like that. But this looks really funny, so you have to make sure that you simplify this as well. Now, I like to put them all as fractions, just to make it a little bit easier. And I do 3 times a to the power of 3 times 1, which if you just put it all together, that's what it becomes. And at the bottom, 4 times 1 times b squared is just 4b squared. This is an expression that is fully simplified. My fraction is totally reduced, and there are no other exponent laws since a and b are completely different bases. Okay, moving on to the last one. Like I said, you want to do the simple exponent laws first. And in this case, there's a bracket, and I noticed that x and x have the same base. But I don't want to leave it in root form. So we're going to change this as an exponent with a fraction, because then I'm going to have a division law that I can take care of. So if you remember properly, the index, which is this number here, goes at the bottom, and then the exponent goes at the top. So same thing here, the exponent is 1. Put the index at the bottom and the exponent on the top. I'm not forgetting about all that to the power of 3, but I'll take care of that after, because I do have something to do inside the brackets. It's kind of like bedmass. I have to subtract my fractions, but keep the same base. So I'm going to rewrite this as 8 over 5 minus 1 over 3. In order to subtract these fractions, I need to have a common denominator. So I'm actually going to have to multiply the left side by 3 and the right side by 5. All this is still to the power of 3. All right, so when I go ahead and do that, I get 24 over 15 minus 5 over 15, all that to the power of 3. I'm going to have to move down here. I just ran out of room. 24 minus 5, you just have to find out what that gives you. And of course, it gives you 19 over 15. All that again to the power of 3. Now, there's nothing else you can do inside the bracket at this point. So at this point, you're going to do your power of a power. Remember that you don't add the exponents. Power of a power means that you multiply. You only add the exponents when you have a multiplication law. So we're going to multiply the exponents. I'm going to put an over 1 so I don't make a mistake. Multiply the tops, which is 19 times 3, which is 57, and 15 times 1. Now, if I use my A, B over C button to check if this reduces, it does. It actually reduces to 19 over 5, which means that I divided the top and the bottom by 3. I keep repeating this in class. Some of you guys are paying attention, some of you guys are having a harder time, but you have to make sure that when you have fractions, any type of fraction, whether it's in the exponent, as a base, as whatever, you need to reduce your fractions. Okay? Any fractions that you see, you need to reduce them. So please, please, please start doing this. Okay? So now you're going to move on. Your homework is right in front of you. So it's on page 79, number 14, 16, 17. That's in your textbook. Okay, page 79. And you have another worksheet to work on, which the supply will give to you as soon as this video is done. So if you have any questions tomorrow, we will go over these things. But it would be a good idea to fill in your foldable as the steps. So I like to recommend that as first steps, you do the primary exponent laws, multiplication law, division law, and power of a power. And as a secondary, then you can go ahead and convert your exponents with fractions and exponents with negatives.